In this video, we're given matrix A, and we want to perform the following operations. First, we want to find the determinant of A. So for this, we're going to use the first row. So we start off with 2, and we hide the first row, first column, and we take the determinant of the 2 by 2 column of 1, 1, 1, 2. And then we subtract, and then we move on to 3. So we eliminate the first row, second column. So we're left with matrix 2, 1, negative 1, 2. And then finally, with the last column, we have 4 here. So we eliminate the first row, last column. So we have the 2 by 2 matrix of 2, 1, negative 1, 1. From there, we take the determinant of these 2 by 2 matrices. So the determinant of the first matrix is 1, second matrix is 5, and the last matrix is 3. Simplifying, we get negative 1 as our determinant. Now we want to find the adjoint of A. So for this, we need to find the cofactor. So similarly to what we did finding the determinant, we'll apply that for every single entry in this matrix. So there's going to be 9 of these cofactors. So starting off with the first one, we have we cover the first row, first column. We have 1, 1, 1, 2 as a matrix, and we're going to multiply the determinant of that by negative 1 raised to the row plus column. So here we have the row and the column, so we're just adding the row and the column, and there you get 1. Now we move on to 1, 2, so it's first row, second column, so now we're at 3. That means we have to hide row 1 and column 2, so we have the matrix 2, 1, negative 1, 2, and because this is 1 and 2, row 1, column 2, you just add those as the exponent. And then simplify, you get negative 5. And then you finish up row 1. So you do row 1, column 3. So that's going to be 4 here. So you hide the first row, last column. So you have the matrix 2, 1, negative 1, 1. And then you multiply the determinant of that by negative 1 and then raise to the row plus column. So 1 plus 3. For that you get 3. And then you continue that with the second row and the third row. So there's 9 of these guys. And we're going to put this inside a matrix. So the matrix looks like this. Plug in the values, and we have now this matrix. Finally, we want to take the transpose of this matrix. And so this right here is going to be our adjoint of A. Now we want to find the inverse of A. So we want to use a formula that the inverse of A is the adjoint of A over the determinant of A. Good thing is we calculated both of these two previously. So recall the determinant of A is negative 1. So 1 over negative 1 is just negative 1. And then the adjoint of A we just calculated. So we're just going to change the sign of everything inside here. And so this is our inverse. Now we want to find A times the adjoint of A. So this is A, and this is the adjoint of A. So the way we multiply is by row times column. And so we get basically the identity matrix, except instead of 1s you have negative 1. Okay, finally we want to solve for x if A times x is equal to the matrix 2, negative 1, 3. So so first, in order to solve for x, you have to multiply both sides by A inverse. So we're going to multiply this from the left because matrices are not commutative under multiplication. So what you're going to multiply by the left. So then A inverse times A cancels. You get the identity. And you're left with x. So that's going to, and then you multiply the A inverse to the left again. So you just want to keep it consistent. Now, the inverse of A we solved for previously as this. So all you do here is multiply these two matrices and get that x is equal to negative 1, 0, and 1. And that is our answer.